Good morning. My name is Lluis Gifre and I'm a research engineer at CTTC in Spain. In this demonstration, entitled DLT-based end-to-end interdomain transport network slice with SLA management using cloud-based SDN controllers, I will showcase a joint effort between a number of partners in the European TeraFlow project. Start with a brief introduction. 5G and beyond network architectures usually rely on multiple transport networks that are interconnected among them with different levels of complexity, size, and technologies used. Transport network slices, in turn, bring flexibility to deploy applications and services, and they are usually flavored with different service level agreements. Orchestrating interdomain end-to-end services poses some challenges because network operators want to keep their infrastructure private, and we need to propagate SLAs to the remote domains. Blockchain technology can be used to interoperate different domains. Permissioned distributed ledger enables assigning permissions to the different records. Also, blockchain prevents repudiation of recorded data and enables traceability of operations. The contribution of this work is the extension of the ETSI TeraFlowSDN controller to orchestrate end-to-end interdomain transport slices with SLAs, and also describing the responsibilities and interactions of the interdomain and the distributed ledger technology components. TeraFlowSDN controller is now part of ETSI. ETSI TeraFlowSDN open source group is responsible for providing a toolbox for rapid prototyping and experimentation, easing the adoption of SDN by telco operators, bringing innovation and contributing to network programmability, and facilitating the demonstration of the different standards proposed by the ETSI groups. When a number of domains belonging to different network operators needs to be interconnected, it is important for the network operators to hide the internal details of their infrastructure. Topology abstraction can be used for that purpose. Each of the domains have a number of endpoints that represent border endpoints for the domain that are used to reach neighbor domains. With topology abstraction, we can define a virtual device for each of the domains, having as endpoints the virtual endpoints, the ones in orange. Thus, the topology resulting of the abstraction should be like this one. Now, let's assume we want to interconnect data center 1 and data center 2 through a transport network slice. Indeed, since we are traversing a number of domains that are abstracted, we need to first compute the sequence of domains to be traversed. For that, we can use a shortest path algorithm. When the sequence of traversed domains is identified, we need to configure each of the different domains independently and instruct them to create sub-transport network slices interconnecting the ingress and egress points of each domain. That indeed implies configuring the different devices per domain. This is the distributed testbed setup considered for this demonstration. The blockchain is implemented by means of a Hyperledger fabric and is deployed at NEC premises in Germany. Besides, at CTTC in Spain, we deployed a number of TeraFlowSDN controllers, one for each domain. This is the microservice-based architecture of the ETSI TeraFlowSDN controller. We highlighted in green the ones that are relevant for this demonstration. In particular, the web user interface that we will be using later, the interdomain component that is used to enable interaction between different instances of TeraFlow, the DLT that provides interfaces with the blockchain, the SBI that provides southbound interfaces towards the devices. We will be using emulated devices for this demonstration. The context component contains a database with the status of different elements in the SDN controller. The pathcom component provides path computation both for intra and interdomain. The service component is in charge of creating connectivity services, and the slice component is in charge of managing the transport network slices. This slide describes the interdomain and the DLT components. The interdomain contains a topology abstractor module that makes use of the events from the context component to recompute the abstraction of the local domain. Then, when the abstraction is recomputed, it is uploaded to the blockchain through the DLT. The DLT, in turn, contains a connector and a gateway modules. The connector is generic and exposes an interface to the rest of TeraFlowSDN controller components, while the gateway is specific on the blockchain framework that is used. Then we define a gRPC based generic gateway API that can be used to extend the pool of gateways. Context sharing between domains is as follows. Every time a change is done in the topology stored in the context component, a notification is sent to the interdomain component that recomputes the abstraction of the domain and makes use of the DLT component to upload new records into the blockchain. On the remote domains, every time a change is done, the DLT component is informed and it retrieves the new records and updates the context component. Activation of end-to-end interdomain slices starts when the slice component receives a request for interdomain transport network slices. In that case, it forwards the request to the interdomain component that first computes the end-to-end path. That means the sequence of domains to be traversed through the path computation component, and then goes to the different domains. For each domain, if it is local domain, it request to the local slice component to create the local intradomain slice, and if it is a remote slice, it requests to the remote domain through the DLT component and the blockchain the creation of the remote transport slice. Let's start now with the demonstration. For this demonstration, we deployed 4 instances of the TeraFlowSDN controller, one for each domain, and connected to a web user interface. This is for domain 1, 2, 3, and 4. Besides, we defined some descriptor files per domain containing the intra-domain devices and links. This is for domain 1, 2, 3, and 4. Let's start by populating domain 1. Okay, so it created 6 devices and 7 links. Now we can go to the context admin that contains the information for the local domain, in particular topology D1. This corresponds to the detailed topology of this domain. We can see the different routers and the data center that belongs to this domain. And also, it creates the inter topology that contains the abstracted view of this domain. So it contains the abstracted view of the domain with the routers and also the data center. We can go to the device section to see the details on the abstracted devices and also the links that connect these devices. The interdomain links are inferred by means of the endpoints that specify to which other device each abstracted device is connected to. Also, if we jump into the other topology and go to device, we can see the details. So we see that the endpoints that connect to other devices are labeled as border endpoints and specify to which other device or domain it is connected to. Now if we go to domain number 2 and choose the inter topology, we can see here that right now there is no local topology for this domain, but we received information from domain 1. That's why we have context D1 here. So if we go to the inter, we see the topology that was received from the other domain. Let's do the same for the rest of the domains. It was received, date, and also here. Now let's upload the descriptor for the second domain. So now if we refresh, we got the abstraction of the second domain. We can check the details of this topology. And if we go back to the interdomain, we get them connected. If we refresh here, we got them. Let's do the same for the third one. Okay, we got here the details of the third domain. we go to Inter, we should get few seconds the complete topology. And if we go to the fourth domain, let me refresh first, there is nothing. We have in the Inter the other topology. If we upload domain 4, okay, and we refresh, but different devices, let's see if in a few seconds they should connect. Okay. Now let's establish the interdomain slice. We define it another descriptor file containing the details of this interdomain slice. In particular, we want to connect data center 1 with data center 2. Remember, this one, the first one belongs to domain 1 and the second one to domain 4. And in particular, their internal connection points that represent the internal gateway of the data centers. Besides, we defined the constraints for this slice, in particular the bandwidth, and a number of settings that in this case correspond to the virtual to the VLAN identifier that we want to use. Now let's go to domain 1. We will choose the interdomain slice, submit. It will take a few seconds to process it, compute the interdomain path, first selecting the different domains to be traversed, and then asking the different domains to establish the connectivity. Now it's done. Let's go first to the slice in the domain 1. We see that it created the interdomain slice, asking to connect the two data centers. And we can see here the constraints and the configurations that were populated. And in this case, this slice is supported by means of subslices, in particular, one local subslice that we will inspect in a moment, and then other subslices in domain 2 and also domain 4. Let's check the subslice that is established locally. It connects the internal endpoint of data center 1 with router 4 at domain 1, in particular the endpoint that is connected to domain 2. It propagated the constraints and configurations, and it is supported by a service, a connectivity service. This connectivity service establishes layer 2 connectivity. It propagated the endpoints, constraints, and configurations, and also it's following this path from the data center 1 till router 4 in domain 1. Now let's check in the second domain. We go here. We see that it created a slice, but first let's check in the context number 2 that contains information that with a request from the domain 1 to slice. We see that it created the interdomain slice connecting in domain 2 the endpoint that is next to domain 1 with the endpoint next to domain 4. And it's supported by, again, by an internal slice, the one that we were inspecting beforehand. Let me jump to the context admin and we can see the details. Again, the same. We can see here that the path for this connection from router 1 to router 4 in the second domain. And if we go to domain number 4, we will jump first, let me refresh, to domain 4, to context domain 4, to see the request from for the interdomain slice. It's asking to connect in domain 4 the endpoint D2 with the internal endpoint in data center 2. It's supported by an internal by an internal slice. And then if we go to the context admin, whatever topology, and go to slice, we see the detail of the slice that is supporting this last segment, and we see that is supported by a service. And if we go to the service, we see that it is connecting router 2 in data center 4 with the internal endpoint of the data center 2. That concludes our demonstration. Thank you very much for your attention.